we're going to talk about how to set up this gas problem so that we can easily punch it out and not make any mistake with our unit values.
4 times 10 to the 6 atmospheres. And then you have 0.05 L equals 1 atmosphere times V2. But you have to make sure that when you're doing these problems, all the units are the same. You have to make sure that like this is atmospheres, right? And this right here, that this is also atmosphere. Like if this is given to you like in torr, it has to be converted. It has to be the same language. They're both pressure, but they have to be like the same language. It might say like on your quiz, what is the pressure in torr?
Then all pressure units have to be in torr. Just make sure that all your units are in the same language. So atmospheres to atmospheres, or torr to torr, or liters to liters. If you're doing an ideal gas problem and you're using R, the ideal gas constant, well, usually most teachers use 0.0821 liters atmospheres over moles times Kelvin. Well, if you're using that R value, then you want to make sure everything's in liters, atmospheres, and moles in Kelvin. But if you're using one of the other less common R values, such as 62.364 liters times torr divided by moles times Kelvin, then you want to make sure everything's in torr. Most teachers tend to use 0.0821 for their R value, so more than likely you're going to want everything to be in liters and in atmospheres.
So for this problem, I'm looking and I'm saying, all right, well, I got everything in atmospheres. I only have 1 liters. That's fine. They're looking for volume. You see, it says, what is volume? So what unit is our answer going to be in? Liters. All right, so we got 4 times 10 to the 6. Leave out the units. 0.05, leave out the units. 1, leave out the units. And V2. So this one is 200,000.